Hello guys! We are students from Don Honorio Ventura State University, taking up Bachelor of Science in Civil Engineering. We are tasked to discuss some sample problems about rectilinear motion as a requirement for our subject, which is dynamics of rigid bodies. So, what exactly is rectilinear motion? Rectilinear motion, also known as straight line motion, is a type of motion that describes the movement of a particle or a body. An object is said to be in a rectilinear motion when two objects are moving in a straight line or are parallel to each other. We have prepared examples about rectilinear motion to share with you. Hopefully, this video can help our fellow civil engineering students. Without further ado, let's get started. Guys, as you can see, we have formulas here which is commonly used in rectilinear motion where D is for distance, T is for time, while A is for acceleration, and V as in victory is for velocity. Under velocity, we have final velocity, which is the V sub F, and V sub I is for initial velocity. Before we proceed, I just want to introduce the GRESA. Using GRESA, we can avoid conflict and misunderstanding in the problem. So G is for given, R is for required, E for equation, S for solution, and A for answer.
So for our first problem, we have an elevator descends from rest with an acceleration of 1.7 meter per second squared until it achieves a velocity of 5 meter per second. Determine the time required and the distance traveled. First, identify our given. So from the problem, we have an acceleration equals to 1.7 meter per second squared. Then our initial velocity, which is 0 meter per second, since it states that it descends from rest. Then our final velocity, which is equal to 5 meter per second. Then let us also identify what are the required here in our problem. So first, the time required for the elevator to reach the ground. Then second, we have the distance traveled by the elevator. For the equation to be used, for time we'll be using the formula final velocity is equal to the initial velocity plus the acceleration times the time. Then for the distance, we can use either the formula distance is equal to the initial velocity times the time plus 1/2 the acceleration times time squared. Or the formula final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. For our solution, for letter A, to get the time, we will use the formula Vf is equal to Vi plus At. So plug in the values, we have our final velocity 5 meter per second is equal to the initial velocity 0 meter per second plus the acceleration 1.7 meter per second squared times our time t. So cancel the 0, we have 5 meter per second is equal to 1.7 meter per second squared times t. Then we can divide both sides of the equation by 1.7 meter per second squared to get our t. Then using our calculator, we can get our time. So t is equal to 2.94 seconds. Then for letter B, we'll get our distance. For this, I'll just use the formula final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance. Suppose that we will be solving this first before our time. And since we still don't know the value of our time, we can use this formula. So plug in the values. We have the final velocity 5 meter per second, our initial velocity 0 meter per second. The acceleration, 1.7 meter per second squared, then our distance d. So cancel out 0, we have 25 meters squared per second squared is equal to 3.4 meter per second squared times d. Then again, we can divide both sides of the equation by 3.4 meter per second squared to get our d. Then using our calculator, we will get the value of our distance. So d is equal to 7.35 meter. But we can also use the other formula a while ago. And it will just have the same value, which is 7.35 meter. So to summarize, we have our answers. T is equal to 2.94 seconds and our d is equal to 7.35 meters.
If a basketball player has a vertical leap of 1.21 meters, then what is his takeoff speed and his hang time, total time to move upwards to the peak and then return to the ground? We will first identify the given. We have a vertical leap or distance of 1.21 meters, an acceleration of negative 9.8 meter per second squared, which is the gravitational force. It is negative because the movement is upwards. And lastly, we have a final velocity of 0 meter per second. Next, we will identify what is being asked. So we are asked to find the takeoff speed or the initial velocity and the hang time. After that, we will list all the equations that we are going to use. We will be using Vf squared is equals to Vi squared plus 2AD to solve for the initial velocity, and Vf is equals to Vi plus At to find the hang time. To solve the initial velocity using Vf squared is equals to Vi squared plus 2AD, we'll be substituting the given. 0 meter per second squared is equal to Vi squared plus negative 9.8 meter per seconds times 1.21 meters. Cancel out 0 meter per second squared. Negative 9.8 meter per second squared times 1.21 meters is equal to negative 11.858 multiplied by 2 is equal to negative 23.716 meters squared per second squared. Now, transpose negative 23.716 meters squared second squared, it will now become positive, and get the square root of both sides. The square root of 23.716 meters squared per second squared is 4.87 meter per seconds. We have now solved the initial velocity. Next, to solve for the hang time, we must find first the time to the peak and then double it. Using the formula Vf is equals to Vi plus At, 0 meter per seconds is equal to 4.87 meter per seconds, the one we solved earlier, plus negative 9.8 meter per second squared times t. Transpose negative 9.8 meter per second squared times t, so it will become positive, is equal to 4.87 meter per seconds. Divide both sides by 9.8 meter per second squared to isolate t. 4.87 meter per seconds divided by 9.8 is equal to 0.497. Multiply it by 2, the hang time now is 0.994 seconds. Problem number 4. A car traveling with a constant speed of 17 meters per second passes a school crossing corner where the speed limit is 10 meters per second. Just as the car passes, a police officer on a motorcycle stopped at the corner of in pursuit with constant acceleration of 2.8 meters per second squared. How much time elapses before the officer catches up with the car? What is the officer's speed at that point? What is the total distance each vehicle has traveled at that point? After analyzing the problem, we can now list down the given separately for the car and for the motorcycle. For the car, we have an initial velocity of 17 meters per second at a constant speed, which means we have zero acceleration. And for the motorcycle stopped at a corner, which means we have zero initial velocity and acceleration of 2.8 meters per second squared. Let us now identify what is being asked. First, we have to find how much time has passed before the motorcycle catches up with the car. Second, the final velocity of the motorcycle's speed. Lastly, the total distance traveled of each vehicle. These are the equations that we are going to use. D is equals to VIT plus 1/2 AT squared, and VF is equals to VI plus AT. To solve using the equation D is equals to VIT plus 1/2 AT squared, let us assume that the distance of both vehicles are equal since it is asked how much time elapses before the officer catches up with the car. VIT plus 1/2 AT squared is equal to VIT plus 1/2 AT squared. Substituting the given values, we now have 0 meter per second times t plus 1/2 times 2.8 meter per second squared times t squared is equal to 17 meter per second times t plus 1/2 times 0 meter per second squared times t squared. After simplifying, we have 1.4 meter per second squared times t squared is equal to 17 meter per second times t. Divide both sides by t, we now have 1.4 meter per second squared times t is equal to 17 meter per second. Then, divide both sides by 1.4 meter per second squared. The time now is equal to 12.14 seconds. Next, to solve for the final velocity of the motorcycle, we'll use the equation Vf is equals to Vi plus At. Vf is equal to 0 meter per second plus 2.8 meter per second squared times 12.14 seconds. The final velocity of the motorcycle at 12.14 seconds is equal to 33.992 meter per second. Using the equation D is equal to VIT plus 1/2 AT squared, we are going to solve for the distance of the motorcycle and the car. Distance of the motorcycle is equal to VIT plus 1/2 AT squared is equal to 0 times 12.14 seconds plus 1/2 times 2.8 meter per second squared times 12.14 seconds squared is equal to 206 meters. Next, distance of the car is equal to VIT plus 1/2 AT squared is equal to 17 meter per second times 12.14 seconds plus 1/2 times 0 meter per second squared times 12.14 seconds squared is equal to 206 meters.
A motorcyclist heading east through a small city accelerates after he passes the signpost marking the city limits. His acceleration is constant 5 meters per second squared. At time 0, he is 7 meters east of the signpost, moving east at 15 meters per second. For letter A, find his position and velocity at time 3 seconds. For B, where is the motorcyclist when his velocity is 25 meters per second? Using GRESA, we have acceleration of 5 meters per second squared, initial distance of 7 meters, and 15 meters per second for initial velocity. So, for letter A, we have to get the final velocity and the distance, while in letter B, we need to get the distance. For our equations, we will use final velocity is equals to initial velocity plus acceleration multiplied by time. And delta d is equals to initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. And also, we will use this equation, final velocity squared is equals to initial velocity squared plus 2 times acceleration multiplied by delta d. After we get those equations, we will proceed on the solution. For letter A, we have a given time which is 3 seconds. To get the final velocity, we have this formula. Final velocity is equals to 15 meters per second plus 5 meters per second squared multiplied by 3 seconds. If we calculate that, we will get 30 meters per second for final velocity. To get the distance, we have delta d is equals to initial velocity multiplied by time plus 1/2 multiplied by acceleration times time squared. We will derive our formula and we will get distance minus initial distance is equals to initial velocity multiplied by time plus 1/2 multiplied by acceleration times time squared. Distance minus 7 meters is equals to 15 meters times 3 seconds plus 1/2 times 5 meters per second squared times 3 seconds squared. So we will transpose the initial velocity. So we will get d, or the distance, is equals to 15 meters per second multiplied by 3 seconds plus 1/2 multiplied by 5 meters per second squared multiplied by 3 seconds squared plus 7 meters. Using calculator, we will get 74.5 meters for distance. For letter B, we will get the distance of motorcyclists with a velocity. We will use final velocity squared is equals to initial velocity squared plus 2 acceleration multiplied by delta d. We have final velocity squared is equals to initial velocity squared plus 2 acceleration multiplied by distance minus initial distance. Our final velocity is 25 squared is equals to 15 squared plus 2 multiplied by 5 multiplied by d minus 7 meters. We will get 625 meters squared per second squared is equals to 225 meters squared per second squared plus 10 meter per second squared multiplied by d minus 70 meters squared per second squared. 625 meters squared per second squared minus 225 meters squared per second squared plus 70 meters squared per second squared is equals to 10 meter per second squared d. To sum it up, 470 meters squared per second squared is equals to 10 meter per second squared d. So to get the distance, we will divide it by 10 meter per second squared both sides. We will get 47 meters for distance for letter B. For our final answers, we have for letter A, final velocity is equals to 30 meter per second and the distance is 74.5 meters. While for B, we have 47 meters for distance.
A baseball is popped straight up into the air and has a hang time of 5.53 seconds. Determine the height to which the ball rises before it reaches its peak. Hint, the time to rise to the peak is 1/2 the total hang time.
First, let us identify our given. We have our acceleration, equals to negative 9.8 meter per second squared. Our final velocity, which is equals to 0 meter per second. Then for our time, since the time required to move to the peak of the trajectory is 1/2 the total hang time, which is given 5.53 seconds. So 5.53 divided by 2 is 2.765. Thus, our time is equal to 2.765 seconds. Then we have our required, which is the height or our d. Then for the equations, we have two formulas to be used. Why? Because to solve for our d, we can either use the formula final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance, or distance is equal to the initial velocity times time plus 1/2 the acceleration times time squared. For these two formulas, we have initial velocity that is required. But since we do not have a given initial velocity, we will first get the value of it by using the formula final velocity is equal to the initial velocity plus the acceleration times the time. So for the solution, first get the initial velocity. So Vf is equal to Vi plus At. Plug in the values, we have final velocity 0 meter per second is equal to Vi plus the acceleration negative 9.8 meter per second squared times the time 2.765 seconds. So we have 0 is equal to Vi minus 27.097 meter per second. Then we can transfer the negative 27.097 meter per second to the other side of the equation to get our initial velocity. So our initial velocity is equal to 27.097 meter per second. Next is to get our height. Since there are two possible formulas to use, I will just use the formula Vf squared is equal to Vi squared plus 2Ad. So plug in the values, we have the final velocity 0 meter per second, the initial velocity 27.097 meter per second, then our acceleration negative 9.8 meter per second squared times our d. So we have 0 is equal to 734.247 meter squared per second squared minus 19.6 meter per second squared times d. We can transfer the negative 19.6 meter per second squared times d on the other side of the equation. We have 19.6 meter per second squared times d is equal to 734.247 meter squared per second squared. Then we can divide both sides of the equation by 19.6 meter per second squared, and we will get our answer. D is equal to 37.46 meter.